Okay then, so today we're going to be looking at hexadecimal. You've already done binary, and binary hopefully you found relatively simple. So if we had, for example, 0, 0, 0, 0, and then we had 1, 0, 1, 0, we would know that if we put our numbers across the top, our numbers 1, 2, 4, 8, 16, 32, 64, and 128, that when we add them together, we should get from our binary number a decimal number, which is 8, 1 lot of 8, and 1 lot of 2. Gives us 10. However, hex was developed to make it easier to read these numbers, because if I was talking to somebody over the phone, they might find this quite difficult to remember, especially if I said, right, the number I want you to write down is 000011010. Or it might be quite easy for me to make a mistake in it when I was typing it. So we've got hexadecimal. Now hexadecimal is a base 16 number system. So we've got decimal, which is a base 10. We've got binary, which is a base 2. Now we're talking about a base 16. So we've got 16 possible numbers that we can use to it. So hexadecimal number systems have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We don't have 10, we have A, B, C, D, E, and F. F being the number 15, but it's our 16th number, so that gives us 16 possible numbers we can use in hexadecimal. How does that affect our binary number? Well, we'll take our binary number 0, 0, 0, 0, 1, 0, 1, 0. You notice I left a gap in the middle, and that's on purpose because I'm now going to use just some very simple ways to work it out into, or convert my binary number into a hexadecimal one. I'm going to put the headings 1, 2, 4, and 8 over the top. 1, 2, 4, and 8. And now I can work out what my hexadecimal number is. Now you notice I've got nothing there, so that is 0. And here I've got 8, 9, 10. So my 10th number is A. So if I'm talking over the phone and I wanted somebody to write this down, I can say it's 0A, and that's equivalent to 10 in decimal, or equivalent to 0001010 in binary. Okay, well let's try. Let's see what happens if we did an F and an F. And some of you are probably already shouting down the screen at me, or at the screen at me, saying, we know, sir, that it's going to be all the possible numbers. So F has to be equal to 15. So let's break this into our 1, 2, 4, and 8. 1, 2, 4, and 8. So we need 1 lot of 8, 1 lot of 4, 1 lot of 2, 1 lot of 1. Okay, so that is equivalent of F. That's equivalent of F. And some of you are shouting already, you know what it is in decimal. So in decimal, what are we going to say? It's all the possible numbers, 255. Okay, so let's just do one last calculation here. Let's do 1, 0, 1, 1. And let's have 0, 0, 1, 1. Now, if I'm converting that into hex, I put my line down the middle. 1, 2, 4, and 8. So my first number is 1 and 2. That gives me 3. And then over here, I've got 8. Let's put the numbers over the top. 8, 4, 2, 1. So 1 lot of 8, 1 lot of 2, 1 lot of 1. 8, 9, 10, 11. Now, we can't have 11, so we're going to cross that out. 11 is equal to B. So B3